So what we want you to do is just imagine that it's actually Friday afternoon. And I know because you're at a conference, you're probably not so happy that it's progressing to Friday so soon, but it's Friday afternoon. But you're not at a conference. You're in the office. So you're working. So you can be a little bit more miserable. That's okay. Now, you're in the office, you're working away, Friday afternoon. You're kind of, just getting through a few bits and pieces. And like all of a sudden,
on. Not again. All right. Let's take that. Hey. Oh. Hi, Melissa. Uh-huh. Yep, of course they did. How much? All right, yeah. Today. Oh, it's important, right? All right, yeah. I'll tell him. Bye.
Sure. So.
Yeah. So, Melissa, yeah, she has a new feature request. We need to change the payment application.
On a Friday afternoon?
Yeah, well, again, because finance actually found out that if we change the name field from 255 characters to 25, we'll save $60.
Friday afternoon, people.
Yeah, and because it's QBR on Monday, it needs to be done now.
So our monthly spend with the cloud is probably what, like $100,000 or something?
Yeah, probably. Well, with the way we waste things, yeah.
And we're going to make a last minute change on a Friday to save $60. Well, why not?
Yeah, Nick, you remember what happened last time? Like when you had to change the color of the payments button?
I thought we weren't going to talk about that.
Yeah, that didn't go very well, did it? Let's not do that again.
All right. So what we want to have to do is we need to make a change. Now, our application, let's quickly cover what's going on with the application. So the application that we're kind of going to be playing around with today is just an MVC6 app. It's literally scaffolded from the web template, and it's using a PostgreSQL database. So it's a very simple application, but that not being the purpose, we want to kind of look at some deployment strategies for it. Now, I've been asked to change the database field length. I'm not a .NET programmer, I'm a Go programmer. I've got no idea what I'm doing. So I look at the code here and I see something and I'm like, well, somebody's put this comment in here. So if I just change the string validation, surely that's going to be fine, okay?
Yeah, well, I'm sure this changes something in the something.
Okay.
Like the programmers shouldn't have left the office early on Friday.
So I'm going to make that change, and I'm going to go through the standard sort of process. So git status.
Luckily, we have automation in place, right?
We do, indeed. Well, we might do. Adding those changes.
Are you going to make a sensible commit message?
No, it's Friday.
Yeah, that's fine. Fair enough.
Oh, well, there's the thing. I managed to type that first time. And I'm pushing it. So whilst we're kind of looking at that, let's kind of dig in a little bit about this because, well, I mean, you came here to talk and learn about progressive delivery. I think we've just proven within the first 5 minutes that you don't actually need it. So
yeah. That went a lot quicker than I thought.
So we can all just go for a beer. But before we do, we should probably just introduce ourselves because if not, how else is anybody going to know who we are?
And buy a beer for?
Yeah. Exactly.
Good point. Let's just go through those slides and then we're done.
Pretty much. We should be out of here in 5.
All right. Don't drop the clicker.
Okay. So I'm Nick Jackson. I work as a developer advocate currently for HashiCorp. My background is that I've been working as software architecture, software development. I've written a book on microservices with another non-Microsoft programming language, Go, but don't judge me. And I'm currently writing a book which is looking at how you can apply architectural patterns to the modern world of service mesh. And as the title says, I am mostly incompetent. But with me, I have my good buddy, Erik Veld, who is probably the Western world's foremost expert in PEBCAC. And for those who don't know what PEBCAC is, it's a problem that exists between the keyboard and the chair.
Yeah, I think that's pretty fair to say. Hi, folks.
So I'm guessing then that we're done.
Yeah. Shall we head out? Maybe like first play a game of Quake or something like that, and then.
Yeah, we could have a quick.
Come on, that's not Melissa again, is it? Oh.
Yeah. Oh, hi there. Yeah. The website's down.
No, it's not.
Are you sure? Well, could you just do me a favor? Just refresh your browser.
Clear the cache.
That didn't help. Can you just go in and clear your cache? That didn't help.
It's DNS. Ask IT.
It'll be okay. So do me a favor. Can you ask IT if they're having any problems with the network? Because we're not seeing anything here, are we? Where everything looks. Hang on one second. Can you check the monitoring?
Sure.
Everything looks fine. Okay, I'll put you on hold while you call them. All right, thank you.
It's not fine. I think everything's broken.
So you go through that process.
Do we maybe have to talk about progressive delivery anyway?
Well, it looks like we do have to talk about progressive delivery.
All right. But, all right, fine. Let's do that. Like, shall we talk about progressive delivery? Like, didn't we do other things to solve for issues?
So the problem is that we literally just push code into production, and we write tests. We write loads of tests.
Yeah, but as we all know, tests are not enough, right? Like, tests basically test our known knowns, right? We write the paths that we actually want to go through in our applications. We define the input variables. Maybe we have some randomization in there, but it's still basically all predefined. Now, what we don't test is users doing really weird things, and we all know they do. Infrastructure changes, another big thing, right?
Configuration changes.
Yep. And sometimes things just happen only in production at crazy times at night where you just can't predict them, right? Like there's always weird occurrences.
Changes that manifest due to load. What we're kind of driving at is that you as an application programmer or an infrastructure operator may not be solely to blame.
No. Well,
Not to blame at all, right? It's always somebody else.
very often it's us, but not always, right?
Now, where you can kind of solve these problems is looking at that deployment process.
Yeah. So if we look at these steps, right, there's basically 5 steps in progressive delivery, right? So the first 3 are code, deploy, and run. And you might all be familiar with that from normal Git flow and CI/CD patterns, right? But where progressive delivery expands on that is monitoring and routing, right? What we're basically going to do is we're going to have multiple versions of our application running at the same time, and then we're going to slowly ramp up the traffic to our new version, and then we're going to observe it to make sure that it's healthy, and if it is, then we're going to keep increasing that traffic until we've entirely moved over.
So we're using just like the Kubernetes liveliness or the Kubernetes health checks.
So actually, those are active health checks, right? Like there's a difference between those. Like this is basically you prodding the application, asking, are you healthy? Are you healthy? Are you healthy? Right? That might not necessarily be true for the end user. So what we want to do is we want to run passive health checks where we observe the system and we're basically looking from an external source how the system is behaving. So think of monitoring, right? We can see what is actually happening in the environment independent of what the application says. So to make it clear to you, Nick, and maybe explain it a bit easier, like an active health check is basically you asking your dog if he's a good boy.
Give me a sausage.
Yeah, exactly. The answer is always going to be yes, give me a sausage. But that's kind of like you writing those /v1/healthz endpoints that only return HTTP 200.
Right. And I think, we joke about this, but the key thing about the health check is that even if you write more information into your application health checks, you're looking at the connection status, you're looking at sort of things like the number of errors that are manifesting internally.
And the dependencies.
There's a number of external factors which may also have a bearing.
Yeah.
And I guess.
Yeah, so a passive health check is more you observing that your couch pillows are all torn over the floor, your carpet is shredded. It paints a kind of a different picture of what your dog just told you, right?
Right. So how are we going to solve the problem? What do we do?
So the main part of it is the Canary deployment pattern. So what we're basically going to do is, as I said before, do the load shifting. So basically, we're just going to do weighted load balancing, if you want to keep it really simple. So we have those two applications. We're going to send 10% traffic to the new version. Then we're going to observe it and actually see, are we getting any errors throughout the entire system? And if that doesn't happen, we're going to increase. But if we do see errors, we can actually roll back and then revert to the old version of the application.
And I guess that sort of fits into a kind of a workflow, and you're going to demo this to us, I suppose.
Yeah, well, let's just do that, right? I mean, we didn't make any errors on stage yet, so.
Well, not yet.
No.
But so did I actually commit the code and push it? I mean, there's a question for you.
Oh, did you actually not break production then yet? Well, that's, I did see push. No, that looks fine.
Okay. Then, away you go.
Yeah, all right. So let's first take a look at what Nick already has running in the environment, right? So we're talking about the payment service. And if we look at the service that we've registered in Consul to do our service discovery and routing of the traffic, we can see that we have just one instance of the application running. Mm-hmm. So I think that's where things went wrong, Nick.
Mm-hmm. I didn't think it kicked off a new build.
Well, that's at least a new failure.
The curse of the demo environment. So what should have happened is when we committed the code, our CI/CD, which we're currently using, Waypoint could be anything, GitHub Actions, whatever you use. It's just a continuous integration flow. Kicks in, and a build will start, and then that build then gets pushed, as we are now seeing, into the production cluster. So we're going to have those two environments running side by side. We've got V5 and V6. And what Erik is going to hopefully show you is how we can slowly kind of migrate traffic between V5 and V6. And then we'll look at a little bit better way of doing it, hopefully.
You want to know the good news, though? That customer that just called us, we actually sent him the right way. It was a DNS problem.
It was a DNS. It's always a DNS problem.
So, yeah. So as we can see, we now have two versions of the application running, and both are registered in Consul. And what we've actually done is we've added metadata to our application. Oh, come on. Let me scroll further down. Oh, you're zoomed in.
Yeah.
There we go. So all the way at the bottom, you can see that we have version V1 because Nick makes pepcakes, and he didn't think that when you release version 6, you might want to change the metadata to version 6 as well. But that's not going to stop us. So what we can do is we actually have the multiple versions running, and we can select the services based on that metadata. So what we want to do is when we say, I want to talk to payments, we're going to then internally of that create two subsets of that, one that will route to that V5 and one that will route to that V6. And then depending on incoming factors, which will change later, we want to either go left or right to either the old or the new version.
So the service catalog is something that's present in most systems, whether you're using Consul, whether you're using Kubernetes, you've always got a way of attributing metadata generally to a service or an instance of a service. And this is incredibly important when it comes to doing something like being able to traffic splitting, because you can't always rely on having, say, two completely separate deployments. You're certainly not going to have two service names. You'll basically just kind of want something to be a subset selection.
Yeah, and it actually adds a lot of benefit, it being a subset, because from the outside world and to the application itself, we're not changing any configuration. So anything that wants to reach the payment service still just addresses payments. It doesn't have to then be like, oh, I now need to route to payments V1 or V2 and things like that, which makes it a lot more flexible. So since we're using Kubernetes, we're going to be configuring the service mesh using CRDs. So first, what we want to do is we want to create this service resolver which will resolve the service payments for us, and we're going to define two subsets. So as you can see here, we say that we want to have subsets, and we've just called them V1, V2, because just old and new. And then we're going to be basically filtering on that metadata version. Now, we're filtering on the metadata, but you can actually filter on loads of different things. If you do name them differently, you could filter on that or use tags or anything like that.
In essence, this is kind of like a virtual service.
Yes, it is. So let's close that. Let's just kubectl apply -f, and then we're going to do the service resolver. OK, so now that we have those two separate virtual services, we now need to find a way to shape that traffic between them, right? So we can do that weighted load balancing. So what we need for that is a service splitter. And it basically does what it says on the tin, which is nice. So we're going to, again, create a CRD for the service splitter, for the payment service. And we're going to split between this subset V1 that we created and the subset V2. And then with these weights, we can actually shift that traffic, right? So currently, we're sending all of the traffic to the new version. But since that new version has that bug that you just introduced, that's not what we want. But just to give you the benefit of the doubt, Nick, let's maybe think that it's to do with load or something, right? So let's just slowly shift back. Because normally when you release your new version, and you're actually doing, like we're basically doing this in reverse now, undoing your pepcac. Normally, you want to release your new version, have no traffic going to it, then send 10% traffic, 20, 30, like whatever you have in your strategy.
So the key thing is, though, that you have to keep doing this. You have to manually keep incrementing the traffic that's going between the split and monitoring it.
Well, if you put it like that, it doesn't sound as...
Well, it doesn't sound appealing for you. We're all going down to the... for a drink, you'll be sitting here until midnight.
Well, no, it'll be fine, Nick. Don't worry. So let me just change this, right? So I want to first send maybe 10% back to this one, and then 90 to that one. There.
This is exactly as if you were configuring like a weighted load balancer. If you were using, you could use something like Nginx to actually do a Canary deployment. How much sort of efficacy you would get out of it, because there's a kind of a number of differing factors, but technically it's possible. What I think, which we'll explain a little bit later on, is that the modern sort of technology like service mesh actually kind of makes the lift and shift of being able to leverage these techniques pretty much transparent for the application and actually a lot easier to configure.
Yeah. Now, as we can see, like just an overview of the routing that we just configured, we have a splitter, and then on the right, you can see the resolver with those two subsets. And if we hover over these little things, we can see that 10% of the traffic is going back to V1, right? Now, it still is actually throwing errors, which we'll see here. So I did the traffic shaping and routing. Now I need to do the observing bit, right? Like we need to externally inspect what we've done. So I have a simple query here for Prometheus, where we're basically going to look at the request per second and the response codes that we get back. And we're going to check if anything is not 200, that's basically an error, and then we're basically going to display that as a percentage of success. So if we keep running these and then scroll down, like I'm actually getting 100% success from Nick, so I think your change just deployed the same one. Nice. But let's assume that it actually was throwing errors here. What I want to do is then increase the traffic back to the old one more and more and more. So I'd go back into my terminal. And
or I can just show you how to automate all of this.
Oh, can we?
Yeah.
Oh, OK, well, then let's do that. I don't want to be doing this every Friday.
We want to kind of show you the manual process involved in something like a Canary deployment because it is quite arduous. And the key thing about an automated Canary deployment is that it should be unattended. It should be 100% automatable. You literally should be able to push your code and walk away. And you should be able to do that with 100% confidence that in the instance that an error occurs or that there is a problem with the deployment, it will be automatically reverted and the end user will be completely unaffected by the change you've made. So when we start talking about, and you've got that unwritten law of, oh, nobody deploys on a Friday because of risk to your weekend. You don't have to worry that anymore because it's not you that has to attend to the problem. The automation will deal with it for you.
Yeah.
So let's kind of take a kind of a quick look at the whole workflow there.
So which bits can we actually automate, Nick?
Well, we can automate pretty much everything. So let's let me just flip my slide here.
Let me just join you in the conference.
So this is a continuous or a progressive delivery workflow. Now, if you look at the top three boxes there, we've got the kind of the code, the deploy, and the run sections. Now, you should be very familiar with this because this is your day-to-day activity. So this is kind of standard continuous integration. You're going to write some code, you commit the code, you PR it. The automation for the continuous integration is going to kick in. It's going to execute your builds, it's going to run your tests, maybe run some functional tests, and then ultimately that will result in a deployment. So again, 100% unattended. Now, if you're not doing something like a Canary deployment, what you're generally going to be looking at is something like a blue-green when you're just doing that straight swap between old and new, which is fine if old and new both work. But in our instance, well, they don't often.
They hardly ever.
Hardly ever. So when you start to look at the automation around the Canary, you basically start to look at building an automated release controller. And that's what we're going to be using. So we have a Kubernetes controller, which basically is Erik 2.0. So
yeah, thanks.
It basically takes on that role. So it's going to be doing the work of monitoring the deployment. It's doing the work of monitoring the application's passive health. And it's doing the work of controlling the traffic splitting should the passive health.
So that's basically everything I was just doing?
Right.
I guess this is how horses felt when they invented cars.
Right.
All right.
Which is also probably when you walked into that bar the other day, somebody asked you if you had a long face. I don't need to explain that.
We weren't sure
we weren't going to do that.
Well, no, that's good.
But I think the key thing is that automation is central. So let's look at the automated approach, and let's look at actually just kind of like how easy things are.
So the nice thing is as well is that all of these top bits we actually have already automated. Like the whole Git flow you have to go through yourself, but after that, until like things land in production, we already have that automated because CI will automatically build and push your packages and things like that, and then your scheduler will actually run your application and keep it running. It's those last bits we need to fix.
So we're going to look at the configuration of Erik 2.0 here, and this is the configuration for Consul's release controller. So what we have here is something that defines a release. So in the beginning, we have the kind of the name of the Consul service, because a Consul service or any kind of service mesh service can differ from the sort of the actual deployment name. And then we have the deployment name, and we're going to use a wildcard. So because of the way that we're pushing, we're not directly replacing our Kubernetes deployments. We increment and we deprecate, just the strategy that we take. And then the more interesting stuff is when we start to look at the strategy itself. So we're going to define the plugin to use is going to be a Canary. We are going to have an initial delay before we start rolling the traffic out. Again, our Kubernetes liveliness and our health checks, our active checks, are going to assure that the application's up and running and ready to accept traffic. But then we're going to start pushing a little bit of traffic to it. We're going to start at 10%, and then every 30 seconds, we're going to monitor. We are going to then increase the traffic by 20%, and if we have any errors, we'll roll it back. Now, in terms of the sort of the queries that need to be applied, well, we're kind of automating that too. So we're just basically saying, hey, we want request success and we want request duration. Now, I can define those really abstractly like this because of the benefits that Service Mesh gives me, because Service Mesh gives me a completely kind of generic approach to kind of standardized health metrics, request metrics that come out of my system. It's not something that's emitted from my application. Literally, my app is just an MV6 scaffold and there's no tracing, there's no metrics, there's no nothing in it.
But Nick, could I do this without a service mesh? Like, let's say a fat client or something like that?
Yeah, I mean, you know, you could, and plenty of people did, but then you've got a sort of complexity that you've got to think about. If you're doing weighted load balancing, you've either got to use something like a centralized load balancer. So you've got to kind of like push things through, like, say, a central Nginx instance. And that was the way that we used to do things when we first started sort of building microservices. But then you're introducing things like latency. You've got sort of complexity around centralized dependency. There's kind of a number of reasons why that is maybe not the best solution today. You can do things with client-side load balancing, so I can deal with this inside of the client. I could write a library which does my upstream load balancing for me, but then I have to maintain that. I have to assume that I have consistency of version and consistency of language across all of my applications in my estate. And the reality is that that's not always possible. So by externalizing all of that, it actually just saves you quite a bit of headache.
It also makes your applications much simpler because they don't have to deal with all those external things, right? You can just focus on writing your core business logic and just have your application only do that. Like, I think that payments application is a great example of that. It basically does nothing with security, does nothing with retries, it does nothing with basically anything. It just concerns itself with, well, putting payments in a database.
Oh, gosh. You know what? So I'm just backing out Erik's configuration here because that will
Probably safe.
cause me issues. And I'm just going to return the system to its previous state. Let me just make sure
I would do a list first, maybe.
Oh, it'll be fine.
That's always the thing you want to hear on Friday afternoon just before going for beers, right? It'll be fine. I think that's what got us into this thing.
Let me just double check that. It'll be. Waypoint.
Deployment, destroy.
Oh, gosh. Pluralization. Nobody can agree on that, can they? So I'm just reverting things back to an original state. So we're going back just to that singular deployment. This is our vanilla cluster.
Luckily, both of them were working.
So now what I'm going to do is I'm actually going to go apply my release configuration. So that file that we've just looked at, I am just going to apply that to the cluster.
So you're using Kubernetes now, Nick?
Yeah.
Could this also work for anything outside of that?
Yeah, so I mean, I think that is one of the benefits of working with a platform like Consul, that it's heterogeneous. So we can work with Kubernetes, with Nomad, with ECS, with the kind of VMs, a number of different sort of methodologies. But like, I think Kubernetes is predominantly the direction that everybody's going in. So it's obvious to have first-class support there. Right, so I'm applying that release. Now, what is going to go on? So the first thing that's going to happen is that the release controller has detected that we've just configured a new release. Now, what it's going to do is it needs to take ownership of the current deployment, because you don't own that anymore. It's now under release. So you can see there that it's cloned the deployment and it's created a new one called primary. Because now when we're looking at a canary, what we're going to be dealing with is the primary and the canary. The primary is the last good known state. The canary is the application under test. So the release controller has created that clone. It's just waiting for it to go healthy. It then creates all the necessary configuration that Erik did manually in order to make sure that all of the traffic is going through to the primary, and then it cleans up and it removes the old primary. So then if we look over into our application dashboard, and there's going to be a little bit of lag in here.
So this is basically, you've applied that and it just puts it in a base state where it's now waiting for new deployments?
Yeah, that's correct. So we'll see that in just a second here, that when this finally gets around to refreshing. that we're going to see that we've got all of our traffic and it's going to be coming through to the primary. Well, assuming that my dashboard is actually reloading, which doesn't seem to be. Oh, there we go. Thank you, dashboard. Again, conference Wi-Fi disadvantage.
That's like the worst thing about if you had to do this all manually. It's like you'd be staring at Grafana for hours and hours, and we all know how painful it is to just wait for it to update.
So the next step is we need to kind of kick off another deployment. So if I go back over here and I go back to my terminal, I'm going to add an update, git commit YOLO v2, because always keep a unique commit message. And I'm going to push that. And I'm actually going to check that it does get picked up by my CI/CD. If not, I'm going to kick it manually. But what we will kind of hopefully see in a second is that the CI build process is going to kick off, and V6 of our application is going to start to roll out.
I think it'll be V7.
Oh, it'll be V7, of course it will. But so that kind of covers those steps. Now, okay, great. The build is going. This is
Thank
good.
you, demo gods.
Right. Now, we're not going to wait for this. What I'm going to do is I'm going to explain to you a couple of caveats and considerations, because what's really important when you're kind of thinking about sort of Canary deployments is that it's not all kind of unicorns and rainbows. There are...
Are we going to the server room?
We're going to go to the server room. So I asked Erik, I said, hey, can you like just build us a Minecraft thing and maybe make it a little, just do it like a Hollywood set.
That's what I did.
You took that to the absolute literal.
What? I made Britain. Didn't, like, there's a kebab shop.
Oh, the
houses.
kebab. So this is a new kebab shop which is just opened, and like allegedly the meat is really fresh.
Good.
So let's take a look at this. Caveats and considerations. Now, the kind of the first one that you need to think about when you're running a Canary deployment is the sample size. And this is probably one of the most important things, because if you're running an automated test, you've got to be ensuring that you're comparing like for like and that you actually have enough traffic to sort of do an accurate analysis. And it's kind of exactly the same as if you were doing any form of scientific research. Now, the kind of the problem with the sample size is how do you sort of get to that? So let's look at a hypothetical situation. So a hypothetical situation is that in a 24-hour period, we have 10,000 requests. And of those 10,000 requests, there's a bug in the system which results in 10% of the requests failing. So we have a 10% error rate. Now, if we want to be 100% certain that when we do our Canary deployment, that we are making an improvement, we really need to kind of push the same sort of traffic at the Canary to be able to evaluate the results. But you can't do that.
Well, does that mean we need to wait 24 hours before we can increase traffic?
Well, technically, we'd have to wait longer than 24 hours because we are only running the traffic as a percentile increase. So we're not really just pushing 100% and 100%. So we're never going to have that validation situation. But it's fine. Because actually, sort of statistics has got our back here. And as I said, it's like a common problem that you find in medical research, that you find in sort of any form of market research, in that the sample size should just be representative. So the reality in kind of statistical research is, like, do I need to be 100% confident? Not necessarily. I'm probably happy with 95% confident. So if I'm happy with 95% confidence, then, like, what is my sample size?
Can you maybe math?
Well,
Explain that a bit, Nick?
I can try and math-splain it, but I'm not particularly the most brilliant person at mathematics. But in statistics, there is a formula which is Yamane's sort of formula, and this is a kind of a simple way of calculating a sample size. So you take the population, which is the 10,000 requests, and you divide that over kind of 1 plus the population, multiplied by the kind of the error rate that you want squared, so 95. All right? So if I look at that here, then actually if we put the numbers in, what we actually get is to get a 95% confidence that we're covering the same number of errors, we actually only need 400 requests, not 10,000. So that's a kind of a standard statistical thing. Does that mean you kind of need to sort of run these calculations? Like, everything's down to risk. And I think that is kind of the key thing in this. And it really depends on whichever service, what you're doing. If you're building just a sort of a simplistic front-end service that has a very low risk, then maybe you'll take a different approach as if you had a high risk, in this instance, payment service. So our release has actually been running here, and what you can actually see, if you look at the yellow line, this is the Canary. The green line is actually our primary, or our last known good state. So the release controller is automatically checking the health of our Canary. It's detecting that there are no errors with it, so it is changing the service splitter automatically by those 20% increments and reducing the primary traffic. So we're slowly kind of switching the traffic over there. What we're going to see in just a second when it completes is that it's going to completely replace the primary with the new candidate, which I'm actually pretty pleased that worked.
Well, it's going a lot better than it started.
So, I mean, I have to sort of put some qualification on this, that under normal circumstances, you're going to be running sort of your Kubernetes clusters and all of your application software on proper hardware. Well, first we were like, well, I'm just going to run it on my laptop. You literally would not be able to hear me speak because of the noise of that fan when I was running everything on my laptop. So we're actually running it on a Scaleway VM in the cloud, which has only got like half a dozen CPUs. I think it only has 2 actually, and 8 gig of RAM. So it's a very limited resource machine, which is why I kind of say I'm pleased that it worked, because it kind of does prove to the testament that you can kind of run a complex system on very limited hardware as well. So that's completely converged now. We're going to look over here into console, and what you're going to see in a second is you're going to see that V7 is going to get replaced by the primary. Just let's dig, before we kind of move on, let's just quickly dig into some of the kind of the logs so you can actually see what is going on inside of the release controller. And if I kind of scroll down here through some logs and I find something that's interesting, here we go.
That one, yep.
So this is the release controller when it's evaluating the passive health of the application. It's literally just executing those queries. Now, it is kind of a predefined query, but it's then just sort of looking at the value, it's getting the value back, the value here being 100%, so it's completely successful, and it progresses. Now, what I'm actually doing is I'm executing 2 queries. I'm executing one, which is the health on the number of requests, so the number of requests which result in an HTTP 200, but I'm also evaluating a request, a sort of a query which is looking at the duration of the service, because I may or I may not, at some point in my career, have pushed dev null to production. And I sat back and I'm like, look at all of those beautiful HTTP 200s. And what I'd actually done was completely unwired the HTTP router, and we weren't actually processing a single thing. So as a kind of an additional check, it's actually useful to also look at the duration of the request, because actually if it's too low, that's a signal that something is wrong. If it's too high, of course, that's a signal that something is wrong.
So in this case, we're like looking at metrics for our service mesh.
Right.
And those are basically internal to the system. Could we also maybe scale on other things, like external things, like revenue or?
Yeah, and so this is an interesting point. And I think when we said that you're looking at the passive data for a Canary, that it doesn't just have to be the metrics of your application. It can actually be sort of external data. So one of the things that we used to do in our production system was we had a pretty good model of the revenue that the business would make on a daily basis. And we used to use that model as a kind of an indicator of system health, because if we were way beneath the target, it was actually an indication that something was not particularly right with the service. And I think you can actually pull those kinds of metrics into a system like this as well and use that as a sort of indicative of systemic health.
And I think what's also interesting is it can be system health, but it can also be like we release a new feature, and is that feature actually more successful than the previous version? If revenue doesn't increase, that could also be a sign like, okay, maybe we need to roll back and rethink the feature.
Exactly.
It doesn't have to be a failure, right?
No, not in the slightest.
Not again, right? I mean, we already did 2 of them.
Friday. Seriously? Go on. I don't want to speak to you.
No, come on. You did last time. Fine, I'll take it. Hey, Melissa. Yeah, no, we were not outside doing anything. No. Uh-huh. Really? $6 saved by changing the CCV code from 5 characters to 3. Fine, we'll do it. Bye. All right, so I guess you already heard. We need to change the CCV codes from 5 to 3. Seems simple enough. We now have automation in place. I mean, if it breaks, we can still go for beers and it doesn't matter.
So we're going to change the CVV code from 5 characters down to 3 characters to save $10.
6.
Oh, okay, well, that's all right.
Yeah.
Now, the kind of like, this is going to break. I mean, American Express uses a 4-character code, so...
But who uses American Express?
Well, I mean, I think we do.
Oh, that would mean we couldn't buy beer? All right, but let's hope it fails and rolls back.
Well, look, I'm just going to make this change anyway because I really just want to get
Melissa
out
pays
of
our
here.
bills. Let's hope this change is better than the last one you made.
Well, I'm not confident. So let's have a look. Git commit -m.
YOLO v3, I think.
This is going to break. Not my fault. And I'm going to push that. So this whole process is going to kick off again. Now, you kind of, when you kind of think about this on the size of it, you think, well, you've got to be absolutely bonkers. You're pushing a change of code which you know is going to be broken. And I think that, that's a very valid sort of accusation. But the key thing is that sometimes you're pushing code that you just don't know. Like you're unsure about, that there could be something that you're not entirely certain about. And it's not something that you can test because, as we kind of said earlier, you're always going to have these issues where there are things beyond your control. It could be external inputs, it could be load, it could be configuration, it could be sort of any of those things. Now, what we should start to see here is that automated release process, but it should automatically back out. Now, there is a little caveat around this.
Should we maybe head outside and talk about retrying?
We can. Oh, it's going to be more interesting than standing at a Grafana chart.
No.
So again, with all of these things, you've got to think about the sort of the caveats and considerations. Now, one of the kind of the things that you kind of need to think about is things like, how do you change data stores? So how do you do a Canary release with a data store? Because if you're making a dependent change on the data store, well, what's going to happen? So that's actually a sort of a very valid sort of thing. And what you need to ensure, if you do have a dependency like an upstream or another data store, is that it works with both versions, the old and the new. So sometimes you have to do like a 3-step process in order to get from one sort of data store or upstream change to another. Otherwise, you've got no way of rolling back. If I change the database and I mutate the data fields, which are dependent on V2, well, I can't roll back to V1 without, again, changing the database. It's certainly not something I can really do automatically without downtime. But it's not such a major kind of deal. I mean, even if you wanted to do something like moving a database field from an integer, from a string to an integer or something like that, you can do it as a two-step process. You know, you can add a new field. The V2 can write to the new field. The V1 can write to the old field. At the point that you're happy that V2 is behaving, you deprecate V1. All of the new data is being written to the new field. You migrate it over, at which point you can then deprecate the field or move things on inside of the database. So it's possible to do this, but it's something you've got to think about. The other thing I think that you need to think about, and we're going to see this in a moment, is that even though we're doing a Canary release, we're limiting exposure of the kind of the errors. We're not completely removing the errors itself. And hopefully we're going to see some errors once we get...
There we go.
We do have a bad version deployed. And that's because...
I'm seeing errors. That's good.
Yeah, we're starting to see some errors here. So, you know, the errors are still getting manifested back to the end user. So how do you cover that? Well, you know, the very simple pattern is that you kind of do a retry on this, because we're only pushing a fraction of the traffic through. It should be safe enough to do a number of retries in order that your downstream service actually hits one of the last good known states. And you can see there that the errors are coming through, and we're going to kind of leave this to tick away, because this is eventually going to kind of roll back, and because we're out of here. I mean, we're halfway to the pub, but like just looking at retries, you got to think about this. So first things first, a retry is not something you should use that masks an underlying problem. A retry is a temporary fix. You don't put retries on your system and expect your user errors to go away and the job is done. No, it's something which is a temporary fix, because the key thing about a retry is you've got to think about how it bears on load. Because a retry adds additional load to your system. It adds additional latency to your system. Latency adds additional load to your system. So a misconfigured or a badly configured retry can actually be damaging to the system. So it's something that you've got to kind of think about. And I think when you're looking at retries as well, you have to think about path awareness, because it's not always safe to just retry something. Now, if you're doing something like a sort of a GET request, an idempotent request, retry, okay, pretty safe. But if I'm posting to create a new payment or I'm sending an email, obviously not. And, well, I can kind of find the right button here.
And the right clicker. There we go.
We're kind of not going to talk too much about idempotency, because it's literally a conference talk in it. Well, it's at least one conference talk in itself, but it's something that you have to be aware of. Whenever you're doing a Canary release, if you're applying something like a retry, are you actually hitting idempotent endpoints? And if not, can you make that application or that service idempotent to be able to do so? So idempotent being that one request results in the same end result. So again, something like a GET, pretty much safe. Like if you're going to do an update, if you update a database table with the same data twice, end result is the same. Now a payment, generally unsafe, because I'm going to potentially take double payments, and let's just apply some retries and see what happens. Because
now, idempotency is not actually something you can fix by using any of these tools. That's something you'll actually have to go into your application, because it's very situation specific. Like, what are you actually doing that it will cause issues? Like, so Nick said payments, right? Like, because every create will just create a new entry, like you might have to solve that either in the application layer, where with constraints, or first checking if something already exists. Or you might maybe want to add constraints to your database, where if you try to do an insert with things that are already filled, it'll just fail, and then your application would have to deal with that.
An idempotent strategy does range. It ranges from as simple as just hashing a request and checking if you've already processed it or there's something in action, to the very complex, which is kind of using the queuing. So again, I'm using Service Mesh to be able to kind of control the aspects of that sort of network routing, I've just pushed some configuration there. I'm going to do 5 retries on those status codes of 500, 501, and et cetera, et cetera. Now, bad request is in there. Ordinarily, that's not something to retry on, but when I built this demo in my...
That depends on where you get the bad request, though. Like in our case, the requests are coming from the API service to the payment service.
Yeah.
Like the API service shouldn't be making any bad requests, but if a user does it, you don't know what you're going to get.
So, like, we're pretty much done here. What you can see there actually is that the release controller has recognized my bad code and it's rolled it back. So that in combination with the retry, well, is pretty much going to kind of cover us from all of the things, and well, we can go to the.
Is that item potency not gonna cause any problems for us, like those double payments?
Well, the double payments. I mean, we've got the QBR on Monday, so I mean, we're going to get a promotion. We've just raised revenue.
Oh, good point. All right.
But you know, very real concern is it's easy to be kind of flippant about these things, but with the right knowledge, with the right approach, you can sort of very, very easily kind of manage these issues. Now, just as a very, very quick kind of TLDR, we haven't talked about the kind of the architecture of the kind of the system that we're running today, because we've kind of more wanted to talk about the process and more about the kind of issues which are surrounding the process. But we are kind of running all of our applications on service mesh. So what does that mean? It means that all of the network traffic is basically intercepted before it hits your application service. So it's hitting the concept of the sort of the data plane and the control plane being in this instance Consul, or it could be Istio or Linkerd. All that really does is controls the kind of the configuration of these little sidecar proxies which sit in front of the traffic of your application. So they're doing a number of different things, terminating TLS being one of them, giving you kind of secure transport, but ultimately what it also gives you is load balancing, which is happening at a local level. So each of these individual proxies is actually dealing with upstream load balancing. It is aware of this kind of like weighted approach, and it's aware of the ability to sort of reconfigure the retries. Importantly, what they're also doing is they're emitting consistent metrics into our system, which is where we're using Prometheus. So the application doesn't even need to be augmented with any sort of metrics to be able to do this kind of passive monitoring. The sort of the service mesh does that for you. As a kind of we talked about earlier, can you do that without service mesh? Yes, like in my humble opinion, and like, you know, take the name and the badge of my shirt away. My humble and sort of professional opinion is that this type of capability, this software-defined network layer is just something that makes it so much easier to build these kinds of reliable systems.
Yes, and it also has the added benefit that you can change this configuration on the fly, because all the configuration that we've been writing, all it's been doing is just dynamically change the configuration of those proxies without the applications being aware.
So if you don't have an issue with item potency, potentially you can use these techniques with your services tomorrow without having to change a single sort of thing. I think we can open the kind of the floor a little bit up to some questions. We do have a few minutes.
Yeah.
I hope it's been useful for everybody. I hope it hasn't been kind of like too much to take in. It's kind of like one of those things which is better to kind of play with around on your own, but in all of the things that we've kind of looked at and we've read, I think sort of the depth around some of the problems is not necessarily apparent, and it's not the sort of thing you want to really learn on the job. Well, remember Paris?
Yeah, no, we cannot do that again. We
that
really need to keep this job.
And
yeah.
So thank you so much.